Hello everyone. So this is Hemang Verma and I am a protocol engineer at Karnot, and this is where I make you understand the project that we are looking forward to, and the basic requirements and the overall understanding that we hope to achieve with this particular hackathon. So this project is called Build Blind Connect. I'm very sure you must have heard of Blind. So Blind is an application where you can post about your job life and things like that, your corporate culture and your company in anonymous mode. So that is where people truly share their experiences and everything. So the best part of it, it remains anonymous to the people who are watching your website, who are watching your posts. So this is what we want to do in Web3 as well. And with Web3, the best part is that we have ZK proofs, and ZK proofs allows to have actual anonymity out there, without actually revealing your identity to anyone out there, not even an application like Blind. So this is what we want to achieve here. And with Blind, we also want to see something like a mixture of unstop. I'll show you what these applications are right there. If we see Blind, this is the application that you can check out. So as you can see, people are posting here with completely anonymous mode. And let's go to Unstop. That's the second website that we have referenced. And then in this website, you can see a lot of things that has job competitions, it has practice matches, it has mentorship, and a lot of things out there. So a lot of events are happening in here, while a lot of posts are being created about XYZ company on Blind. This is the kind of relationship that we are looking forward to while building this application called Blind Connect, wherein people can post anything. It could be a confession or it could be prediction markets. Yes, you heard me right. It could be confessions or prediction markets. What do I mean by that part? So you can create an interface wherein people actually could post anything. Let's say what's gonna happen to this particular person or this particular company, this particular CEO or something like that. Any kind of event out there. Think Farcaster, how they allowed events into their application. That is the level that we're thinking of going. And all of it while truly achieving anonymity. And how do we do that? We use web proofs. So this is the example, and these are the few websites that you can actually use to achieve that. They allow you to achieve, like they allow you to have web proofs made of absolutely anything that you're doing digitally. A good example of that would be, let's say I'm posting something about Karnot itself. I'm sharing an experience about Karnot itself, and I want to achieve true anonymity, even from the like website or application like Blind. I want to ensure that like Blind wants to ensure that only Karnot employees upon only Karnot employees are actually posting stuff about Karnot, and I want to ensure that my identity is not revealed, my email ID is not revealed. So what you can do with these web proofs is you can create a web proof saying that whatever post is coming from this particular person is actually coming from this particular email ID called himang@karnot.xyz. And websites like these will create a ZK proof of that by ensuring that yes, whatever has been stated is actually correct. And then that ZK proof can be used to showcase applications like Blind or the Blind Connect application that you'll be making to show that yes, this proof is actually valid. And that's absolutely amazing. You can truly achieve anonymity without revealing your identity to anyone, and that's just amazing. So this is the kind of project that we're looking for. The core value parts of it, I have described it here pretty well, that we're looking for something that's community driven. We're looking for discovery and validation, looking for trust in the anonymity that we want to provide, as well as we would like you to focus on the business model as well as to how you can make this grow. We just don't want you to be restricted to a hackathon only. We want you to go beyond that, and Carnot is ready to help you with that. We're going to be helping you in hosting the chain. We're going to be helping you in providing all the infrastructure needed to actually get this running. Like that is the extent that we're ready to go with you beyond this hackathon. So build a good project, build a good UI, build a good application, check every nits and knots, and make sure that your application runs very well and very smooth. And don't worry about the infrastructure part, because Carnot is here to handle that. And we would not want to see this just as a hackathon project. Rather, we would want you to continue it later on the line and build something crazy out of it.
All right. So this is Amal Verma, and in this video, we'll be talking about this particular project that we want you guys to build, that is build blockchain native AI agent economy. So think of it like this. We have a country, right? All of us live in a country. And in this set, we have a country that is running based on economy, based on socialism, based on a lot of things out there. What we're looking for in this project is a roll-up that has AI agents and not humans doing transactions. So everything that happens in this rollup is governed, defined, and executed by AI agents themselves. There's no interaction of a human on this particular application. A good understanding of this idea can be taken by this particular video from the founder of Virtuals himself, who talk about this idea in much, much deeper sense than we are going to be talking about right now. We're more focused on the technical aspect of it. Uh, where essentially in this segment we're looking for a completely self-driven autonomous financial entities. Those are going to be the AI agents working with native account abstraction and doing self-executing smart contract transactions. So that's a lot of technical jargon. Let's break it down. So what is native account abstraction? So before understanding native account abstraction, what you need to understand is what will be providing you is going to be Madara chain. And Madara chain works on the exact same spec as what Starknet works on. So essentially, if you have any documentation and if you can find any documentation on Starknet, it is completely valid for the Madara chain that will be giving you. All right, so that makes life easier, much, much easier. So if we go to the standard documentation of what native account abstraction is, we get to understand that an account in Starknet is not just a simple account. It is much, much, much more complex than that. It is actually a smart contract, and that means that you can write your own smart contract which follows the spec or interface of an account, and you can deploy your own custom built account. That means you can have various logics out there implemented and executed before you actually do some sort of transaction. For example, I have to give XYZ amount of value tokens to ABC guy. I can do that on every transaction. Whenever I'm doing some other transaction, this piece of code can automatically get executed because it's written in a smart contract before the transaction actually happens. So that is something cool that you can do. You can do much, much cooler things out there. And I think that is why it makes sense for these AI agents to be able to use this native account abstraction because this allows them to write custom logic. This allows you as the user to write custom logic that you would want to define for your LLM or your AI agent to actually be able to execute. So that's what native account abstraction here means. Talking about self-executing smart contracts, so think of it like this. Um, for We're going to be showing you an example in the workshop following after this video in which we are talking about a dApp called Greedy. So for that particular dApp, we could not do a lot of transactions over the network. We did not want to do that. Rather, we wanted to do transactions inside the sequencer itself. So we actually went out to the sequencer, that is Madara, and we changed its code base a little bit to be able to do some transactions internally itself. That is much, much faster than what we could achieve over network. Similar sort of thing is something that you could actually be going through when you're talking about self-executing smart contract. That means let's a particular function of a smart contract is called every X amount of times. And in that smart contract, you have a list of transactions that your LLM would want you to execute or automatically. And you can feed in data and it will get automatically executed. So that sort of thing is what we're looking for in self-executing smart contracts. And so all of it breaks down into a decentralized AI to AI commerce, wherein AI agents are working towards economy that is driven by them. They are making trade, they're minting tokens, they're doing whatever they would want to. Because in the end, it's a country built by them, right? So they can do anything out there. So that is the kind of idea that we're looking for, wherein your AI agents are smart enough to, make a trade. And actually, one thing that you can do that is coming on top of my head right now is that you can use oracles a lot. You can custom build your own oracles, that simulate a country into this particular roll up, wherein you're feeding in some data, and according to that data, these particular AI agents are responding to that by minting tokens, creating tokens, or something like that, or by doing some other kind of transactions out there. So that is one thing that you can try out. One thing that I wanted to focus on particularly well is why roll up. So there are a few points that I have about that. The first thing would be that this autonomous contract extraction, like greedy, that we are able to, feed the transaction inside sequencer by the sequencer itself and not send them through network, is something that is much, much powerful and something that you cannot do with any public blockchain out there. It's something that you can do with your own blockchain. So that's why a roll-up here makes sense. Secondly, it would be the custom gas tokens that you can build. Your AI agents could be smart enough to, build and create different custom gas tokens that you can use for. Then this is also not something publicly available on the blockchains out there. And this third thing would be ZK LLMs. So think of it like this. Everything that your LLM is giving as an output, that this is something that I want to do, can be provable later down the line by using ZK LLMs. We will be providing some links to read about that. The point is, something like ZK-LLM requires a lot of compute, and that lot of compute cannot be processed and carry forwarded on top of a public blockchain. So for that, also a rollup makes much, much more sense because in here you're looking for some particular values that you want to extract out of that blockchain. Rather, a public blockchain will just allow you to have a generalized sense of value. So this is one thing why rollup makes sense here. Now, talking about the technical and infrastructure side of it, it is by far very, very known to all of you that we'll be helping you in, figuring out the Madara code. We'll be helping you in any changes that you would want to have in Madara code, and we'll be providing you with RPC, with a faucet, and Explorer URL so that you can fiddle around with your particular rollup and deploy multiple contracts out there. And we want you to ensure that you have, an autonomous contract that your AI agent is able to use and work. So that is one thing. For the Celestia DA layer, we do have some ideas as to how Madara and Madara Orchestrator itself uses Celestia DA. But if you guys are looking for something much more particular, please do feel free to hit us up and we'll help you out in there as well. Coming down to the last part, that is the business model. Think of it like this. We understand that it's a month-long hackathon, right? And you cannot devise this complete technical architecture with it, which in itself is going to be much, much difficult to execute, while also ensuring that you have a very good understanding of the tokenomics. So we understand that, and what we would want you to do is to just have a sensible understanding of what this whole system can run as an economy, and focus more on the technical side of it and make good UI, make good UX, make amazing LLMs and amazing interactions that they can have and just sail your way through it. So this is the overall understanding of this project. If you have any doubts, please feel free to ask us. Thank you so much.
All right, guys, now it's time to talk about Madara. All right, so Madara is a powerful Starknet client that is written in Rust, and that client essentially means that it's a full node as well as a sequencer. So, what is Madara exactly? So, think of it like this: whenever you're doing a transaction on blockchain, it's being handled by someone. That someone is Madara right here. Let's go deeper. Let's go deeper. So there is a chain. There's an L2 called Starknet. I'm sure you must have heard of it. It's giving good results out there. So it's a ZK chain. That means everything that you do here is provable as well as it is powered by ZK. So Madara is an open source contributor that has the capability to read and to sequence any transaction and to execute any transaction that is happening on Starknet, as well as it also supports an L3. That means you can build an app chain on top of Starknet, and that is where Karnot comes in. We help you enroll up as a service and we help you create your own chains. All right, so this is what we're going to be talking about, and we're going to set it up. We're going to understand how we use it. We're going to understand Starknet a little bit. We're going to understand how we can interact with it. One thing before that, we need to understand that every link that I'm providing here, and every link that I'm going to open here, I'm going to be providing it in the documentation that I'll be sending with this particular video. I'm very sure you can find it as a link down in the description or something. All right. Okay, let's proceed further. So understanding Starknet and how to contact Starknet. So think of it like this: when you're talking to Starknet, it's essentially you're giving out a transaction, and the transaction is being executed and everything like that. Madara is an open source solution to executing the transaction as well. So what we can do is we can create our own chain using Madara, and we can execute transactions on that, and we can do everything that every L2 and L3 out there is doing. So, in a sense, everything that you can use to contact the Starknet sequencer, you can use to contact Madara as well, because they are built on the same specs. So, for example, let's go to this website. Starknet.js. So Starknet.js essentially is a JS library that you can use to contact, the Starknet sequencer, do transactions, retransaction, and everything out there like you would do in any other blockchain. So here's an example. Let's see how to interact with your contract, right? So it would be giving you multiple examples and multiple understandings of what all you can do with Starknet.js. Remember, whatever you can do in here with Starknet, you can do with Madara as well. So that's the beauty of it. So every piece of code here, we're gonna try out some pieces of code here on Madara and see if it works or not. So that you can understand how you can use this tech stack and build your own app chain. So first things first, let's start with Argent. So I'm very sure you must have heard of MetaMask, right? MetaMask is utterly famous out there. Similarly, to contact Starknet or any other Starknet-like chain, you can use multiple wallets out there. One of them is Argent. So let's go to Chrome extensions and download that. All right. So let's quickly set it up, add to extensions. Yeah, so we have Argent. Let me set it up real quick. So I'm very sure I must be seeing something in here. All right. So what's happening right now? I have a particular account on my mainnet. Let's zoom in. All right. I have an account on my mainnet and it's called Pluriperg. All right. So I can use it and I can see that I have 0 tokens in here, 0 Ethereum, 0 Starknet. So one good thing about Starknet is that you can use Ethereum as well as the Stark token that is native to this chain as the fee token. So that means you can use 2 tokens as fee tokens. So that's pretty interesting. And so right now it's pointing to mainnet. All right. So what are we going to provide you? Let's talk about that. So we're going to provide you a hosted Madara. So it's like this. We're going to provide you this link, Madara test.karnot.xyz. That essentially means we have hosted a Madara for you. We have done the initial basic setup for you. And now you can use it to build app chains on top of it using Cairo. Cairo is the provable language wherein you can write smart contracts for Starknet and like chains. So for example, you can use Solidity to write smart contracts for Ethereum. Similarly, you can use Cairo to write smart contracts for Starknet. So yeah, we're gonna see that. We're gonna see an example of deploying a dApp over on our Madara chain and testing it out. So what do we have here? We have a Madara account and we have an Argent wallet. So let's do one thing. Let's add a new network, because essentially what we're going to be doing is we're going to be contacting another network that is not the mainnet or the devnet. So let's add that right here. Let's go to advanced settings. Let's go to manage networks and let's add some networks. So I'm going to call it Madara chain. You can name it anything in your local self. And I'm going to get the chain ID. So the chain ID is here as Madara devnet. All right. I'm going to just put all caps Madara devnet. Let's put the RPC and sequence URL. Let's see if we have anything else to talk about. This is going to be pretty much same fee token address. So this token address 049D. This essentially is ETH that is bridged into Starknet and like chains, and it remains pretty similar in terms of the hash when you're setting up Madara as well. So you not need to worry about that. Let's get the block explorer URL as well. We have that right here. I have deployed that for you. So let's go to Voyager. This is the Voyager that we have deployed for you. So similar to Etherscan, right? That you'll have in Ethereum. Etherscan. Similarly, you have Voyager in here and Starkscan. So we have two types of explorer. We're going to be using Voyager in here. So I'm going to put that in here and let's create. All right, so we have added Madara chain to our account. We still don't have any account on Madara chain. So let's first switch to that. You can switch it from here. And now you can see that you don't have any account. So let's try to get an account. So I'm just going to go on and, choose a standard account in there. And yeah, skill sneak. Nice. So yeah, that's there. So now you can see I have 0 Ethereum in here. So we're going to get some Ethereum. All right. How do we do that? For that, we'll be providing you a faucet. So let's go to the faucet right here. First of all, let's copy the address. All right, I'll save the recovery first. That's very important, guys. I hope you guys don't lose your recovery phase. I'm just gonna be back with this. Alright, so I've copied my recovery phase and I've saved it in a pretty good state. Now I've copied my address. I'm gonna go to the faucet, and this is the kind of faucet that we'll be providing you guys. And we just put our address in here, as you can see, and let's claim our ETH. And if everything works well, we're gonna have some amount of ETH in our wallet pretty soon. So let's wait for that. Alright, so I can see that my transaction has gone through. Let's check it out. And the transaction and this particular transaction will automatically redirect me to the correct voyager that I have set up, because that is what we have entered in the faucet as well. So we can see that we have sent some amount of Ethereum. Let's check this out. Your balance is 0. Let's see, let's wait for it. It took its time and now it's showing. So yeah, you can see 0.1 ETH right there. It's not giving a USDC value because we have not configured that in Madara chain. That's pretty fine. But what you can see here is that you have 0.1 Ethereum. That means that you can use this amount of money to do transactions now. So let's try it out. So let's send some Ethereum to some random account. I'm gonna get some random account, all right? So I have some good amount of accounts deployed here. Let's choose any one of them. And you can see the private key, it's fine because this is just a test net. So don't worry about that. Don't go blaming on, Discord and everything. All right, so let's send some money. I'm gonna put some address in here. Sometimes it's gonna say that you need it to be 66 character long. So that's usually is resolved by just adding a 0 right after the 0x. That's because sometimes the address that you get is truncated to 64 characters usually. This was 65, I think. Let's send some money, 0.02 to this particular address. All right. And this is going to be failing to load transaction details because it's like Argent does not know this particular chain, because this is a chain that I've spun recently only and I've not registered it to the, sort of like whitelist on Argent. So Argent is saying that, bro, I cannot trust this. So let's go ahead. It's our chain. Nothing's going to happen. Let's see if our transaction went through, and yeah, it went through 0.0 ETH, 08 ETH. And let's see the transaction on the Voyager that we have. I don't know how to click that. Oh, okay. So let's check Voyager right now. The transaction cannot be found. All right. It must be that Voyager has not indexed it yet. Oh, my bad. It's because the Voyager link on Argent that we set up, I think did not went through. So I'm just going to copy this and I'm going to go here and I'm going to add this transaction right here. And yeah, voila, we see it. So you can see that we have done a transfer. You can see that we have done a transfer from which account to which account to an account which has 079C. So that is going to be somewhere right here. Oh, it's going to be an event, right? So let's check out this one. Oh yeah, from this guy. We have sent the transaction from this guy. So this guy is nothing but this is the ETH address. So this means that this particular amount of ETH has been transferred. And let's go to this. That this is the sender address. Let's check that out, whether it is a sender address or not. Yep, it matches. So this transaction looks pretty neat. Yeah. So now what do we have? Now what's the state that we are in right now? We're in a state wherein we have been able to understand what Starknet is up to some extent. We have understood what Madara is doing, and we've understood what Argent is and how we can, add an account to Argent, get that account deployed, and use that account to do real-time transactions. For example, this transfer right here. Now what we're gonna see is we're gonna start deploying stuff. So we have a dApp running, like we have a dApp code that we have, and it's written in Cairo, of course, and we're gonna try to deploy it and see how it goes about. So I'm gonna talk about the dApp for a moment right now. The dApp essentially is an advanced version of Minesweeper. All right. So what we're gonna do there is it has a lot of bots that you can play with. A lot of people can deploy a lot of bots, and each bot has to mine a particular tile. A tile could be either an empty tile, or it could be a bomb, or it could be a diamond. So by mining a diamond, you get enormous amount of points. By mining an empty tile, you get some amount of points, but just because you're staying alive and you're not dead. and by mining a bomb, obviously you blast off. So this is the game wherein multiple people can deploy multiple bots, and each bot is doing a transaction every second and things, and they're trying to find as many diamonds as they can, and the player with many diamonds and many points wins. So this is the game, and we have a Cairo contract written for it. I'm going to show you that as well, and we're going to deploy it, and we're going to see, and we're going to do a mine transaction. So that is how I'm going to show you how we can write a Cairo contract, how we can deploy that Cairo contract. We're going to be using Starknet JS scripts. That's right. So let's start. So I'm going to show you the contract right now. So the game that we have named it as is Greedy. All right. Yeah. So let's go to the GitHub. This is the particular GitHub repo that we have. It's all private right now, but don't worry. While you're seeing this video, I'm very sure it must be public already. If not, hit us up. All right. Let's go to the contracts. These are the contracts that are being deployed for this. Let's check it out. So there are two types of contracts: a bot contract and a game contract. Game contract essentially describes the tile. So tile is something that's going to be a matrix. Think of it like a matrix wherein every tile has a point, and you're going to be going through random points to figure that out and mine it. So this is the game contract. It has an interface, main.cairo, and a types file in which you describe different things that you would want to have. It's pretty similar. The structure of it, how to understand it and how to write it, is pretty similar to Rust as well as Solidity. It inculcates good and both values from it. And yeah, I think it's pretty easy to understand. You will get a hang of it. The best way to understand Cairo, I think, is using the Cairo book itself. Let's check it out, the Cairo book. So this describes everything in Cairo that you would want to understand. This is like the Solidity book, if you remember. That's one thing. Now you're gonna find this similar book for Starknet. You're gonna find an architecture diagram for Starknet and everything. We'll be linking that down so you can check that out as well. So let's go back to the contract. So this is like disable contract, update executor address. These are some internal functions that we would be using. And this is an example of deploy a bot wherein a particular player is requesting this game to deploy a bot for them. So this is how it goes about. Then is the mine function. The mine function essentially is trying to understand and check all the guard clauses and then finally mine a tile for that particular bot. So this is what this guy is doing. And similarly, we would have the bot folder, which would have the interface that the bot is going to go through and talk about. And then we're going to have the main.cairo file that is executing all these particular functions. All right. So this is how it looks. Now this is about the Cairo side of the program, of the dApp that we have. So what we're going to do is we're going to deploy this dApp into the Madara chain, and then we're going to be trying to mine a particular tile from some bot accounts that we're going to deploy. All right. So and I have a script for that. I'll show you that as well. This is deploy.js. This script essentially has a lot of configurations that I need to talk about, and then it has a lot of Starknet JS code, as you can see right here, that is helping me with all the deployments and everything. All right. So a quick example for that would be like this. This one down here. So we have many types of transactions in here wherein I can directly declare and then deploy the game contract, or I can actually declare it and then wait for a while, then deploy it. And I can do other things like add block points to the game, enable the game contract, declare bot contracts, and etc. Specifically call mine at 6. All right, so this is what we're gonna try out. So let's spin the script up. I usually do that using my pre-written commands. Yep, right there. So what I'm gonna do is I can actually talk to the Madara that is running right here. So let's go to this guy and actually set this up right here. So yep, right here. So this is the Madara that I'm going to be talking to. Let's see if I need to change anything else. Deployment postponers, all of these things come later after we deploy the particular contract. And I'm going to be needing two particular addresses. These are nomenclatures in respect to greedy. So let's choose any two account. I'm gonna choose 17 and 18, and I'm gonna put that right here. Again, there's nothing wrong with showing this particular private key because this is a test chain. Yeah, and we're gonna set up everything else later on while we are, doing the transaction. So the first thing I'm gonna do is declare and deploy game contract. So I have some specification that I've already registered here. That's like the width that I want and the height that I want, the number of diamonds I want in the matrix, and it would automatically randomly choose some points to deploy the diamonds on. Similarly for the bombs, and what's the mining point going to be looking like, what's the diamond value, that means how much money or how many points you're going to get if you mine a diamond. There's always room for optimization. If you find any in the greedy contracts, do hit us up and we'll be gladly accepting it. It would be much appreciated. Let's deploy. So right now what is happening is it has created a game class hash. I'm not sure if you can see this. I'm going to zoom in right there. It has declared a game class hash, and now it's going to be using that to deploy the contract using the constructor arguments that we have defined right there in the config. So let's wait for that. All right, so as you can see right here, we have gotten the contract address and we have gotten the transaction hash as well. So what we're going to do is we're going to go copy the transaction hash, go to Voyager and just put it right there and see what it hits up with. So this is the sender address. Let's check if that is correct. The sender address must be the sequencer address if I'm not wrong, or the executor address actually. So this is the executor address 4C6A5 and yep, 0x04C6A5. So this is the transaction that we have. It has launched some events, that is like contract deployed, ownership transferred, and etc. And this is the call data that we sent with it. That essentially means the constructor arguments that we sent, and it has gone through. So the transaction has gone through. And then if we check out the contract address, let's search it here and see if it comes up. Yeah, it does. So this is the contract that we have recently deployed, even though the source is not validated because we've not sent the Cairo program to Voyager to validate it, but that's fine. That's not an issue. So this is what we get as clash hash that we must have seen somewhere right here. Exactly. So that means we have declared and deployed the game contract. So there are some minor changes in the deploy script that we need to do right now. We're going to copy the contract address and we're going to put it here. This basically means that this is the address of the game that you need to talk to for the next transactions. Let's restart it. Now we have done -1. That essentially means 0 and 1 together. Now we're going to add some block points to the game contract. Let's see the code as well. Let's see the code for that. So I'm going to go almost down and then I'm going to search for this particular function that I'm using. So this is declare and deploy. That is what we did right here. Let's also check that out. Let's also check this out. Let's go. Yeah, so this is what it was doing. It prepared some call data. That was because of the configurations that I had, right? And then it called this .account to declare and deploy. This is a function that Starknet.js provides you. Once again, we're using Starknet.js to talk to Madara. Why is that? Because Madara supports all the RPCs and it has the same specs as the Madara sequencer. So it would automatically work. So yeah, this is what it is. Declare and deploy. This is what we use to deploy the contract. We wait, and after waiting for the transaction to complete, we have the contract hash ready, contract address ready, and the transaction hash as well. So this is declare and deploy. Let's see what add block pointer game does. So we're gonna find it here. Update block points. So this is gonna be generating a lot of random points that is configured in the in the number of diamonds and number of bots that we saw earlier, and it's going to be using that, and in chunks it's going to be sending some transactions. That's going to be like, this is the diamond, this is the bomb point, and just please register it into the contract. So let's check it out. So as you can see, I'm chunkifying it so that because I don't want to send a lot of data in a single transaction, and that just helps in maintaining a lot of things. And usually sometimes it fails because it's just not able to process that many tiles and that much data together. So what it's going to do is it's going to deploy these particular diamonds in a loop, So it's gonna do 500 at a time. So let's wait for that. All right, so we're back. And as you can see, we have deployed all the diamonds and all the bombs into the contract. And let's check out any of the transactions right there. Let's go to Voyager. Let's put the transaction hash right there, and we must be seeing it now. So you can see that this particular transaction has happened already. And that's about it. This is what we get. So let's check it out. Let's check what we have apart from that. So we have declared and deployed a game contract, and we have done some transactions to add the block points into the game contract. Now there is something called enable game contract. So let's check it out. This essentially is a piece of code in the contract. Let's check it out. A piece of code in the contract disbands it from doing in transactions to start the game before we actually enable it. So we're gonna go to the main and we're gonna find and check enable. So there's something like a flag called contract enable, and this flag is only turned, it's false as you can see right here, and it's only turned when you do this particular transaction called enable contract. And are we doing the transaction? Let's check it out. So you can see that this is the enable game contract code, and this is the enable game contract JavaScript code, and this is where you're doing the transaction, you're estimating the fee, and then you're executing the transaction finally. So we're gonna do that right there, and let's wait for it. So we have the transaction done and we're good to go. So what else do we have? We have declare bot contract. So this essentially means that we're declaring the class hash for a bot contract. We have done everything for the game contract, and now we have something to do with a bot contract. So let's declare it. It's something similar to the 0 and 1 point, that is, declaring a game contract and then deploying a game contract. I'll zoom in a bit more. It's similar to that. So we're gonna declare a bot contract first, and then we'll be deploying multiple bot contracts. Meanwhile, it's going on. Let's check how many bot contracts are we gonna deploy actually. Okay, so we have the class hash, we have the transaction hash. So I don't think we need to check it out as well, because I think I trust Madara enough that this transaction has gone through. So let's go to deploy multiple bots, and while we are doing that, let's check out one thing. What is going to be the number of bots that we're going to be deploying right now? First things first, we're going to change the spawner's address because it's referring to some old state of Madara, and bot address would be updated after we have deployed the bots. So the spawner is essentially, think of it like as players, and I can get the players from right here, as you can see right here. So I'm going to copy some players right here, and I'm going to use them to deploy the bot contracts. Again, this is nothing specific to Madara or Starknet. This is just how the contract is written, and this is how I have to interface with the contract to be actually able to deploy the bots. Now coming on to the number of deployments per spawner, that is 90. There's going to be 90 spawns of bots per contract. It's going to be a hefty bit. I'm just going to go and change it to 2, and that means I'll have 8 bot deployed. I'm just going to add that here after they've been deployed and try to see transactions. All right, so let's cancel it, let's restart it, and now we'll be deploying multiple bots. So as you can see right there, it's preparing to deploy 8 bots using a multi-call. So as you can see right here, we have successfully deployed the bots, and let's again check it out. Now, one interesting thing. With this piece of code, we have done one thing. We have emitted an event. Let's check it out. Where is it? Let's go to deploy a bot, and this is the event that we have. No, not this one. This is mine. Yeah, this is the event. So this is the event that we have emitted with this particular transaction of deploy a bot. We have just called this function, and we're going to check it out whether it actually shows up on Voyager or not. So this is where we're going to go. We're going to see the events, and as you can see right here, these are the bots that we have deployed, and this is a spawn bot transaction. Can we find out the bot address from here? We can. This is the bot address. Does it match to the bot address? Oh, I don't have bot addresses here. Never mind. What I can do is I can just copy this bot address from here for all the 9 events that I've launched, and I'm going to copy that into the bots array that I have. I'm going to do that real quick. All right, so being honest, I felt lazy and I did not went through for all the 9 bots out there, but I got few, I got 5, and I think that should be fine. So we're gonna restart the script again, and now we're gonna call mine for these bots. That means any of these bots could find a diamond, could find an empty tile, or they could find a bomb and get killed. So let's check it out. Let's press 6 and let's launch it. So it's gonna call mine and it's calling mine for all these 6 bots. Let's see the code right there. Let's just copy it. It's gonna be easy. So yeah, this is the call mine that we're calling, and you can see it's gonna call the batch mine. It's giving an error. Let's come to that. Let's see the code first. So this batch mine is something wherein we're gonna contact the game contract. So that's where it's being built up, and then we're gonna start with the nonce of the sequencer. That bro, I'm gonna talk to you and I'm gonna deploy some contracts, and then we see and we call mine here. This mine is essentially where we're saying that we have these multiple mines and these multiple bots and I want to mine for them. So this is where the code relies. Now one thing I'm seeing is that I think I'm doing something wrong here by putting a hard-coded value for the loop. I think that's not gonna work, and I think that's why this is failing, this fetch is failing. So I'm just gonna correct that and come back real quick. All right, so I've not tested this code yet. We're gonna test it out together. What I've done here is I saw that there was a random number 5300 that I must have used sometime earlier. I changed that to get the length of the pods list that I've defined above and use that to loop through and populate this particular multi-call that I'm gonna send into the array. So that is where I'm doing call.push, and this Cairo felt right there I star 7, that is I multiplied by 7. It's essentially a salt that I have to send. So what happens is the Cairo contract takes this salt and some block number block hash and tries to create a random block point that this particular bot is gonna mine. So this is what this is happening. So I could actually change it to anything out there. I just kept it I multiplied by 7 just for the sake of it. So then there's a call push, then there's going to be a sleeping, and then we're going to be checking out the promises and executing them. All right, let's check it out if it works. All right, operation failed. Results is not defined. I'm doing something wrong in this piece of code. Let's check it out. This is batch mine, and we have results. Oh, my bad. Oh, I've not defined results somewhere. Lol. Does that mean the transaction went through? Because if I'm seeing this, let's check out Voyager now. If we go to Voyager and if we go to the pending block that is out there, and if we see the transactions that we have, I don't have the transaction hash, but yeah, let's check it out. This is 31 minutes ago. All right, and this has 2 events. This is tile mined. All right. So I think the time is sort of not in sync, but what we have here is a tile mined transaction. And this tile mined transaction must be coming when we must have spawned the bot. So I remember this particularly well. Whenever you spawn a bot, you get a tile mine as well. So it's because you're spawning a bot on a tile, right? You're not spawning it in a random place. It's like snake and ladders. You have to start from zero, right? So what is happening here is that you have deployed a bot onto a particular tile and it has mined that tile as well. I actually this is what we can see. So this is how a tile mine looks like, and this is emitting the events, that is this is the bot address, this is the points that it got 0x0a. And if we're gonna check that in here, let's go to the converter. 0x0a is essentially 10 when converted into felt. And is that what I kept for an empty tile? That is correct. This is what I kept for an empty tile. That means this tile has been mined successfully and our code is working. Even though the last part did not work, the call mine for a batch, let's ignore that and see at look at the bigger picture. We deployed a dApp. We contacted the contracts in that dApp. We set them up. We deployed them. We added block points, and now we're able to do mine on that as well. So this is how it's gonna look like When you're creating your own dApp and you're trying to deploy the pieces of code for that, this is what it's gonna go look like. You're gonna be setting up Arch, and you're gonna be getting token and funds from Fossa and everything like that, and you're gonna be deploying your own Cairo contracts, and that is what we are waiting for. That is what we are looking for. You making amazing applications out there, amazing app chains out there, and we helping you out in the hosting part of it. Don't feel restricted to reach out to us. If you want any changes on Madara, for example, let's say you have a particular piece of logic that you cannot just execute with network calls and something like that, we can change some pieces of code in Madara itself for you. After all, it's an open source project. Why not? Right? Uh, we can change it, we can tweak it, and we can host that custom Madara for you, and you'll be good to go. So this is the dApp side of it, this is the transaction side of it. And on the one hand, where there is Madara, there are other repos associated with it. There is Madara Bootstrapper, there is Madara Orchestrator. Madara Bootstrapper is something that helps us set up everything, the account, the bridge, and everything into the Madara. And then there's the Orchestrator that does all of the side transactions that Madara is not handling. For example, Madara is ensuring that your transactions are settled and what do you call it, accepted on L2. As you can see right here, this part is being done by Madara. It's handling your transactions. The accepted on L1 part is something where the orchestrator works on it. Takes a transaction, it proves it, it does a lot of computation on it, and then it settles onto L1. That is the orchestrator's part. So that's about it, and that's about this particular setup instruction. Feel free to reach out to us. Feel free to ask us any questions as much as you want. I have asked a lot of questions while understanding the whole system as to what it is today, as to what I have an understanding of today. And it would be much appreciated if you devote your time into building something crazy out there from the projects that you've described. I'm sure you must have gotten the understanding of them as well. One more thing. We'll be providing all of this into our documentation. You'll be getting all the links and everything into documentation. So you need not worry about that. And yeah, that's finally it. Thanks for watching. Bye bye.